tomorrow will be better. In this question, a car has run into an obstacle, and upon investigation, the police found out that the braking distance, which means the distance from the time the car applied the brakes till when it hit the obstacle, was found to be 22 meters. And further investigation revealed that the deceleration was estimated at 7.2 meters per second square. With this information, we would like to know at what speed was the car moving before brakes were applied. Follow me, dear friends. Solution. They are asking here for the speed. Now, first and foremost, what do we have? We have the braking distance, we have the deceleration. We do not have the speed. But there's another information which is the final velocity, which we can pick from the question. How do we obtain this? From the moment we know that this impact is going to bring the car to a stop, we can conclude that V, the final velocity, is 0 because upon impact the car no longer moves. Now, it's a deceleration. We want to assume that this was a constant deceleration. It didn't before stopping. It decelerated uniformly till an eventual stop. So we will use one of the equations of uniformly accelerated motion because it was a uniform deceleration. Now, which of these equations are we going to use to link both what we are looking for and what we have? The best of these equations will be v squared equals u squared now minus 2as. Why do I use minus? Because the question has made it clear that it's a deceleration, which is a negative acceleration. This is the same context when we are dealing with gravity. The moment the projectile opposes gravity in its initial state of motion, the acceleration is going to be negative g, not positive. If you are still struggling with this, subscribe to my channel. Now from here, this is what we are looking for, and this is what we will make the subject of the formula. Now, take into account that this is 0. Therefore, u squared, let's start with u squared, will be equal to, we send all of this component to the left, and of course the sign will change, and it becomes 2as, no longer negative. To make you the subject, be careful, don't say divide both sides by 2 because this is an exponent, not just a factor. So what we will do is we will take the opposite of this operation, which is a square root, and we will do this on both sides, okay? So we will have here that u will be equal to the square root of 2 times the acceleration and then times the braking distance. Now you have all of these quantities. Leave your answer in the comment section. Let me help you by numerical application. 2 times 7.2 and then times 22. Drop your answer in the comment section and tell us in which unit your answer should be expressed. Tomorrow will be better.